Don't forget it. Okay, I'm here. um, nice. Okay, I'm in. Okay. Oh, I don't need this. This is me thinking about something from some stream. It's kind of annoying. Okay, you know what? I really like my argument because it was simple, but it just doesn't work. I don't know why. Thunder, Wagon. I'm doing good. Thunder, hope you are. Ooh, it's been a minute since you've gotten first. Oh, I was about to shout you out. No, I want to check how many firsts you have. Fermi trick disappear. All right. Well, thank you for saying hi. It's been good to have you around again. Um. Yeah. Okay. So what I was doing right before the stream, well, right before the stream, I was thinking about a geometry problem someone's working on. Before that, though, I was doing this freaking branch point problem still. That I was doing in the last stream too. Tendarios, hey, thank you for the work. And I've done it. So I did it the other day and I got it completely wrong. Well, not completely wrong, but I got it pretty freaking wrong. So I want to come back to it today. And I've done the first one right, as far as I know. The second one, I nearly have it done right. I can't justify why part B has a branch point at infinity. I know it's supposed to. I don't know how you show it. Hey, Pablo. Oh, I guess I was just like talking through it. The short answer is the question at the top here, part B. I'm trying to justify why there's a branch point at infinity. Um, and so I've done a substitution with z equals 1 over t. I found the limit goes to infinity as t goes to 0. But that doesn't mean it's a branch point necessarily. And so I'm trying to do a small circuit around t equals 0. But it's not really working out. It's not doing what I want it to do. Um, Let me look at the book and see if they do, like, for... They start off with an example of root z. How do they justify the branch point infinity for root z? Well, for that it's easier because... Oh, wait. Maybe Hmm. No, maybe not. I was thinking maybe I should, instead of doing a small circuit around 0, should I do a small circuit around like 1 or -2? Or both? Hmm. Oh, this song. Sorry, it's a little bit too loud, isn't it? Do. The song's a banger though. I really like it. Um, yeah, for root Z, it's actually not. It's kind of easy to do the infinity branch point. Skirtle, thank you again for the emotes. I promised you an alert, did I not? Let me bring up Stream Elements and play that. Daniel Dan, welcome in. Um, sorry, I'm trying to multitask and failing at it. I hope you're doing well. The theme of my streams are basically math help, and when there's any question from chat, I just kind of choose something to study. So I am working on a complex analysis question with branch cuts. I had to do any level of like math question though. So if you want to ask like, or if someone asks like what 2 + 2 is, I would answer that. uh, no, it's fine, Skirtle. It's a slow time in the stream. This is an alert that Skirtle made, and I just found where to play it. Oh, I hope that the sound levels at a good thing. I think I tested it, but it was kind of weird. Oh, it's double playing. That's why it sounds weird. Sorry. There we go. That's how it's supposed to sound. Yeah. I love the face that I was making. Yeah, so that's for 105 bits. Complex numbers. Oh, nice. Yeah, you don't have to if you don't want, but if I'm sure like what your like background in math is, or maybe you're just here for games or something random too. So yeah, I also stream games like DayZ is one of my favorites. I want to get back to playing Sifu. And then like I need to get my Factorio playthrough on track again, but that's been it's coming up on a year, I think, which is really bad. I love Factorio and they released DLC for it. Slim, thank you for the raid. Hey, Mouse. I am. Yeah, so for anyone who's here on my end, check out Academy of Useless Ideas, aka Slim. Awesome stream where he talks about just pretty much anything and everything in math. And actually, Daniel, for anyone else who's new, I do have like a list of people who I like to like recommend in case you're interested in math streams in general. I just recently expanded it. It takes up 2 whole messages now, which is kind of awesome. It used to be only 1 message. Oh, I didn't make that, Mouse. I'm sorry. You're at 35 bucks. Oh my god, thank you. Okay, you know, I can literally make it for you right now, Mouse. What did you want it to say? Or what should we make it say? It doesn't take long. Mouse. Is yeah for anyone who's like the actual education? Oh, nice. Yeah, Dr. Gold is awesome. Mouse command. Bam. Command triggered. And so I think I was doing the same problem on Saturday or something, and I got it pretty terribly wrong. And so I was revisiting it off stream, and I didn't manage to finish it before the stream started. I think I've done part A correctly. I'm on part B, and I'm trying to justify why it has a branch point at infinity. I've justified the other 2 branch points, but there's a 3rd one at infinity, and I can't quite figure out the argument. Best mouse in the world, or Love is Poison? Okay, you know what? That gives me an idea for a 3rd option that you didn't say. Okay. I mean, okay, yeah. See? How's that? But yeah, if people in general want to have just like a fun little quick command like that, feel free to just ask. If you're into YouTube current events thing, you can explain Fizba's joke about V Shoujo? I don't know who V Shoujo is. Pablo posted a question in Discord. Okay. Math question hard. I appreciate the warning. Oh god. Oh yeah, this was this was the I was working on the branch cut stuff off stream, and then I saw a problem on Slim stream that made me start. That was my little scratch work right there. But the argument I was trying to make doesn't quite work. I couldn't figure it out for n equals 6, so I gave up. Tiny hands rules. Okay. Let me. I'm gonna get this question on screen, and then I'll make you a command 2, Rex. What is this? Oh wait. We have to figure out what the sequence is. But all these limits are pretty easy, right? Oh no, it's not easy. There's an n in front. Okay. Let me make Rex's. Commands. Oh, we're gonna have another Poison Mouse Day on Thursday. Oh, Pete. Thank you so much for the Prime, dude. Holy crap! I'm so glad that we're able to get a session in, dude. Poison Mouse Day, yeah. Um, yeah, so the plan for tomorrow, the stream was probably, it might start a little bit late depending on how things go, but if you've been on the stream for a while, you know my friend Pete, aka Unbind. Um, we're gonna be playing some Daisy tomorrow. Every day is Poison Mouse Day. How about that, Rex? I feel like I've seen this question before. So I'm sorry, I'm all over the place right now. Um, no worries, Rex. But yeah, okay, so tomorrow, Wednesday, will be Daisy with Pete, aka Unbind. Thursday will be Poison Mouse, whatever he has to throw at us day. um, and so yeah, Mouse, whoever you want to invite, just like let me know and I can send him a message, or you can if you want. Or just like the usual suspects, maybe. I don't know. Slim and Fembox? All right. If they want to and they're around, they're welcome to. And I'll send him a message if I don't see him say something here. He roars too much. If I haven't missed anyone's message, I don't think I have. Is this music still? Did I turn it down? I turned the music a little bit up because there was a good song playing. Hopefully the music is at a good level now. Hey, Aditya. Claw looking good, chicken bucket. I don't have that set up because I'm using Spotify and you're not supposed to use Spotify. That's the song that I'm playing right there. The playlist that I'm listening to. Is that one. It's against Spotify's terms of service. Hey, Filter, welcome in. Gasp. Spotify is it's just a program that it's like Netflix for music, I guess. Like you pay each month and you get basically every or just plays music for you. Yeah, Daniel, that's kind of what I figure. Definitely not use L'Hopital's rule. Well, L'Hopital's won't work immediately because of the N in front. It kind of messes up everything. Oh my god. Wow, that's actually okay. I Slim just DM'd me. I made this picture of you, and I want to show the picture here. Like for so few lines, it actually looks really good. Like honestly, he could open one. Internet plus SIM card gave Free Perplexity Pro? I don't know what you're talking about there, Adia. Make this your poster? Honestly, it wouldn't be a bad one for like an avatar. Nice. Perplexity is AI. Oh, I don't want to use AI. So Pablo, like, where did this question has a competition feel for me? Like, where's this question coming from? $200 for you. Got it for free? Oh, nice. You followed after you were brought in Eats to a Pirate, new math community here, very supportive of each other. Oh, awesome. Welcome in. Yeah, no, there's a small but very connected math niche on Twitch, and I think it's really awesome. Like, there's just some really cool people who I've met through doing this. So this list is probably like a little bit overwhelming, but this is like the list of people who I like can recommend the most. From a competitive exam. Yeah, because I got a feeling I probably can't do this question, Pablo, is the issue. Eyes, when you hurt yourself and you shout, "Aye!" All truckers use Spotify only for years. Yeah, I don't imagine they'll actually get in trouble, but yeah, exactly. The pattern is pretty hard. Like, I don't know what the pattern is either. Offhand, they might expect you to. You might need to do some work. To be able to figure out what the pattern is here. Yeah, especially because like the leading coefficient especially is very confusing. -3n, 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 then randomly -7n. Uh, Pablo, I think this one is probably just I think I just can't do it. What I can do is Google it. It's from JE Advanced. Yeah, I can't do JE Advanced. I'm sorry. I've seen this exact question before. This link was purple. You're somehow supposed. Okay, you apparently just find the pattern. Uh, I can give you this. I can't do this question. Um. So yeah, sorry, Pablo, but that's the best that I got for you. Mouse, did you say that you have a question? You do it on Thursday? Okay, sounds good. Yep, Pablo, I've tried many JE advanced questions before, and I generally just can't do them. So if you're pulling a question from there, just kind of please don't. The, I just can't do them. I'm sorry. Oh, awesome, Daniel. Wolfram Alpha, I don't know how you. The issue with putting that into Wolfram Alpha is I don't know you need to tell Wolfram Alpha what the pattern is, but if you know what the pattern is, that's like the hardest part of the problem, it seems. So it might be the hardest part. I didn't look too closely at the solution that we looked at. Okay, so maybe instead of taking that as my thing of t, maybe we want to take whatever's inside the parentheses here as our 1 over t, as our thing. What do we end up with? So if we have that, we want that, we add 3 to each side. And then we're going to throw away anything with epsilon squared, because we don't like epsilon squared. I guess that's how we justify that infinity is a branch point. Because this, I think, is more clear why it's a branch point. You posted a question? Okay. I am going to slam this into Google Translate just because I don't feel like trying to figure out what it means by guessing. That works too. Let me see what Google Translate comes up with. And see the set of complex numbers. Oh, you know, I really didn't need Google Translate for this, I don't think. It's actually, it's kind of, I should have just tried to read it first, because this is actually really similar to the English. Why do they just randomly give us I to the 17? So these are some very weird conditions to work through here. Yeah, I know we can simplify it like that, but like it's adding just a tiny bit of extra work for no real reason, it feels like. All right, I guess let's start chopping our way through this. Not 13. 3. Yeah. So W1 squared 1 plus 2i root 3 minus 3 over 1 plus I to the 17 is equal to I to the 16 times I, and I to the 16 is positive 1. So it's just I. So I plus root 3. Now we need to do this division, and I'll do that division by rationalizing. I should probably simplify. Minus 2 plus. Now it's too crowded. There we go. Minus 2 plus 2i plus 2i root 3 plus 2 root 3. 1 plus 1 minus root 3 minus I. Okay. This is just busy work so far. So these twos will all cancel from that fraction. Like, this has no relevance to the actual problem, which is annoying. So we'll get minus 1 plus root 3 plus I 1 plus root 3. Yep. Minus root 3 minus I. The minus root 3's cancel. So we get minus 1. And then the minus I and the plus I cancel. So plus I root 3. Is that right? Feels too simple. Okay, right. So I guess we're gonna need to find the argument of this, so we can do that. Pablo, not if it's from JE. Sorry. This is second quadrant? Bruh. Pablo, I guess do you already know the answer to the question? I prefer to do like homework help where people actually need help with something. You're just like kind of quizzing me. I prefer not to do it. Okay, in that case, then if you want, you can post it, and I always like try it. Thank you, Mouse. That's third quadrant. I messed this up. Is there a double negative? I I've forgotten how you like deal with this for arctan. It's kind of bad. Like how you fix the quadrant after you take arctan. I need to remember like review how you do that. Okay. Not like that. Thank you. Well, yeah, but okay, or I guess I don't remember that alpha is positive, I guess. Janie, the question is right there on the screen. Sorry, I'm just checking what was posted in the Discord. I'll look at it more in a minute. Okay. Sounds good, filter. Um, Consider z equals x plus I by I. Jenny, I don't quite. I'm still trying to figure out what the question is asking, to be honest. So I have a hard time explaining it. I mean, I'm kind of just reading this as saying, like, this bit here, it's like sweeping out an area starting at 2 plus 2i. Um, and so it's sweeping out, like, starting from here up to 2 pi over 3. It's like somewhere there-ish is a piece. It's just from Poison Mouse in chat. I don't know where he got it from. I think this was like a difficult university entrance exam, like, or a relatively difficult one to the other ones. So the real part of where's my cursor? Oh, I'm writing white on white. That one's it's the real part of z plus I is less than or equal to 2. What does that mean? The real part of z plus I, starting from there, that means like x is just less than 2. Like, isn't that just everything like there? The plus I part does nothing in this condition. I don't think. Well, I'm thinking about the conditions right now, Mouse, I guess. I mean, it's just saying that x is less than or equal to 2. This one is saying that minus y plus 1 is greater than or equal to 0. Which means y is less than or equal to 1. The real part of I plus z, it's not quite z, because z has an imaginary piece. Filter, you have to imagine that z is a real part plus an imaginary part. So if you take the real part of z plus I, you'd want to first write it as x plus iy plus I. And then you chop off that piece. Yeah. That just means set a variable w equal to this, and w1 and w2 are given. It is just a constant. Yeah, for whatever reason, they just make you do some computation before you can actually do the problem. I don't know why. So is this oriented the wrong way? Yeah. That's probably a good translation. How do we make these conditions? So the second two conditions tell us to be in this region, but the first condition tells us to start from up here. How does that make sense? Mouse, or at least how I'm reading the conditions is the second condition tells us x should be less than or equal to 2. The third condition tells us y should be less than or equal to 1, which means we're down here in this region. But then the first condition feels like we need to be outside of that region up here. And so I don't know what to draw. Pablo, I'm starting on a master's soon. Hardlocked, thank you so much for the tier 2, dude. Oh my god. First. I appreciate you, dude. It's very kind. in applied math. When I become king of the USA, I'll remember you. There you go. Gotta get in early. Um, yeah, Mouse, I know all of that. I don't know how to bring them together. I feel like they're conflicting. Am I supposed to do more work with the arg bit? Like, should I actually be taking an arctan? Oh my god. I get it. God. Stupid mistake. The thing I didn't know was to rewrite it like this. So I was looking at positive 2 plus 2i. I should have been looking at negative 2 minus 2i. Okay, this makes sense now. So at this point, we have an angle of 2 pi over 3. We need to get the area of it. Okay. Well, we have a rectangle there. I shouldn't trust... Well, no, the width is 4. The height is 3. The area of the rectangle is 12. The area of the triangle it's height 3, base... We need to do some math. 2 pi over 3 minus pi over 2. It's an annoying number. Pi over 6. There we go. That's unit circle. 1/2 times height 3. The base is 3 times tangent pi over 6, whatever that is. Tangent pi over 6 is 1/2 divided by root 3 over 2. So 1 over root 3. Or 3 over root 3. or root 3 over 3. So we get 3 root 3 over 2. So I think the final answer, A equals 12 plus 3 root 3 over 2. I don't think I care to get a common denominator. Is that right, Mouse? What is NEAT 2025? That was just a different entrance test. All right, Masters, there's a few questions that are waiting, so I'm moving on. But if I made a mistake, then tell me. No worries. This was the answer that I got here. $24? Oh, it is like a trapezoid. That is a formula, right? I guess I made an error somewhere in here. If I use the formula for the area of a trapezoid, it's the average of the two parallel sides. 4 plus 4 plus 3 tangent pi over 6, which is just root 3, times the height of 3. No, Mouse, I got the same answer. I did 12 divided by, or I did 24 divided by 2. Like the over 2 is only there. So this is the same answer. All right, nice. Well, Mouse, I did it. This is the right answer. It's the same as the answer that you posted. we sorry, there's just a few questions that have stacked up, so I'm trying to get through them. If you want to, I can come back and explain something, but it's all good. No worries, mouse. I'm a little bit taken aback by I don't know what the string getting slack means. Like in terms of the physics. I want to just use energy though. I don't know if this is valid if the string is slack is the only thing that I don't know. There's zero tension. I guess that makes sense. It is valid. I guess let's see what V over V naught is in this situation. Oh, can we even find that? We're gonna we need another piece of information, don't we? So I would like to just divide through by that or something. But that means we're gonna end up with the V naught squared over here, and that seems bad. Okay, see ya, Adia. Yeah, Pablo, I don't really know what to do with this. I don't know what the condition for the string to become slack is. That's my issue. Hey, color cone. What is this centripetal acceleration? Is equal to horizontal acceleration? Okay, I'm just gonna use this because I think the only thing we really have to do then is take this equation and divide it through by 1/2 mv squared. So we're gonna get v naught squared over v squared is equal to 1 plus mg L plus L sine theta over 1/2 mv squared. I think I didn't like this v squared on the bottom, but we can use this equation to sub out that v squared. Lg cosine theta. M's cancel, the 2 comes up top, that v squared becomes Lg cosine theta. The L's cancel, the G cancels. I think it's what we're getting. I guess now we can get a common denominator. How does that simplify? Uh, okay, it doesn't, so I apparently did something wrong. The G canceled because of this substitution. Is this supposed to be v naught squared in this problem? Actually, no. And what Pablo wrote, Pablo put in for that v squared. And then we don't get... Yeah, I think I just don't know. This isn't making sense to me. I don't know how to make them look like my answer. I don't see any similarities. We can go to Desmos, but I don't feel like my answer is going to match any of these. It's not that. It's not that. And it's not that. Yeah, but if everything's to the power of 1/2, we just need to match the inside. I mean, does that... I mean, I guess maybe there's some weird trig stuff that's happening. I feel like I should only need to match the inside, but we'll look at it just to be sure. Nope, doesn't change anything. Pablo, they don't match. Like, I just looked in Desmos. It literally... I don't know how. And it doesn't look like it expands to me. And even if I did, it's not going to match because, like, look. They're just not the same thing. So yeah, Pablo, I'm sorry. I don't think I can do this problem. Like, it... Just because they have some overlap doesn't mean it's the same answer, though. This work is wrong. No, nobody's here. This is what I got. It doesn't match any of the given answers, though. You're basing this off ChatGPT? ChatGPT is wrong about this. Like, this answer is verifiably wrong. String... why do we care about theta equals 0? Like, it should work for theta equals 0, but like... And the other choice is 3 at 0. Your answer is 3 at 0, none of the choices... Okay, yeah, there. Sorry, Puika, I didn't understand what you're saying at first. So yeah, Pablo, ChatGPT, it can do things right sometimes, but you shouldn't think it's fact. This is saying option 4. G sine theta equals mv squared over L. This is saying sine theta instead of cosine theta. I don't know how to verify that part of the problem. Apparently the only thing, like, I think the only thing we have to do is replace sine theta with cosine, or cosine theta with sine theta. I don't know why. Uh... Sine theta, sine theta. But then that does match. It's supposed to match something. It's supposed to match option 4. I'm still doing it wrong somehow. Oh, I'm flipping. Wait. Oh my god, I'm getting V naught over V. I'm supposed to get V over V naught. That's why it looks off. So I need to take this and flip it, and then this is the right answer. There we go. So it's option 4. Yeah, don't trust ChatGPT. Yeah, square root. Who cares about that? Okay. There's another question that was posted. But wait, what? 7 to... Okay, so that feels... Wait, why is this not an S? Oh, because it leads with a 0? Okay. So you consider it a 6-digit number, apparently? At least one appears exactly twice. Nope. Can't do this one either. Oh my god. Just cases? Lowercase digits? What the hell? That's like a fun question, though. All right. I don't know do the question. I'm just gonna link this because uh I'm pretty bad at combinatorics. Yeah, that's a question, Slim. I really don't feel like thinking about it right now. I'm kind of already annoyed from the last few questions. I'll show it to you, but I really don't want to spend time on it. I don't know. The solution that I saw online was just going through cases. Uh, which seems like a kind of boring way to do it as well, but that's the only way that I would know how to do it also. Okay. I think I did answer this question. Find for complex analysis. Let me just verify the answer. It's 2.3 number 1. Wait. Sorry. No, I'm not done. I didn't read the answer to part B. It was just the important one, or the one that I wanted. I want to think about how these branch points are. So we have 3 branch points. How are they actually being drawn? We have a branch point at +1 and -2. And infinity. So I assume we're gonna choose like just one point to be an isolated point and the other one goes off to infinity. Um, okay, if we measure them all, I mean, I guess if we measure them all from like 0 to 2 pi, actually no, I don't think it's that bad. If all the angles are measured from 0 to 2 pi, I think we just get branch points like that, or like branch cuts like that, like isolated point cut off to infinity. And then I think the other option would be choosing that point to be isolated and that one off to infinity. And I think you would achieve that by measuring like this one from -pi to pi. Okay, that's what I thought for the branch cut for that one. I don't, maybe I should have thought more about that end piece there. Real, the branch cut is for real part of Z. Oh no. Really? The the branch cut? So the branch cut just plows through one of the branch points. They're just taking the branch cut like that. I guess I need to think more about this. So I'm measuring angles from 0 to 2 pi. So if I make a small circuit around here, +1 doesn't cause any trouble, infinity doesn't cause any trouble. This point doesn't cause trouble until we start to actually enclose it. And then we suddenly jump. So I guess that's why we have a problem area here. Same thing, we measure this from 0 to 2 pi. Well, I guess. How would this look in the inverted plane? I assume it's kind of unusual to draw branch cuts like this, but I'm kind of curious. what it looks like. Like, because it feels like we're getting just that entire bar there. And you know what? Branch points might not be there. Maybe they would be. I guess they actually would be. Um, oh, okay. I think I see it now. So it is just going to be this bar in between here. Because when we do this, if we're measuring everything from 0 to 2 pi, we get an issue between these 2 points because of this point's discontinuity. We get an issue between these 2 points because of both of their discontinuities. But then when we do the final circle around this point on the right, it's a cube root. And we've now stacked up 3 discontinuities, all adding up on this piece. And so we actually are returning to our original value, I think is the point. Okay. Okay. That makes sense. It's always such a tricky thing that I need to get used to with branch points. Okay. I know people are sick of me talking about branch points in the same problem for multiple streams in a row. I could completely like switch topics, which I was thinking about starting to mix in diffy cues. Yes, I'm spending so much time with them because it feels like a really important topic. It's so hard to think about them for me. The book really glazes over it. But it's cool because like you can use uh like the fact that log of z has branch points is what allows you to count um like the winding number and stuff like that. So like I think it's really cool that this thing that should be an inconvenience, annoying thing, you can kind of make useful. You know what? I do have a really stupid hole in my knowledge of diffy cues, which is how integrating factors actually work. And not just memorizing the equation to use an integrating factor. You keep looping on the log, you get the winding number. Yeah, exactly. Because the winding number comes from like 1 over zeta minus z, or whatever, which integrates to some kind of log. I was an integrating factor for like non-linear, which I really haven't used. Maybe this is a good example to read through. Oh, you know, I should probably start with 2.1. I'm on 2.6. But this example has kind of intrigued me. differential equation can be written as d phi dx plus d phi dy dy dx. Okay, yeah, true. The dy dx is just translating that y prime. I thought it came from like a chain rule thing. I was trying to figure that out, but it's not. Oh, it's like we set up the result of the chain rule, and now we're actually using the chain rule to get to the simpler looking thing. So yeah, it's just an ordinary derivative of d. Wait, no, that's psi. D psi dx. I called it phi, I think. Hmm. Wait, but is psi the answer to the question? Oh, okay. When psi equals a constant is the answer to the question. Why is that? You know, that is okay. Maybe the book will go on to I don't get the exact relationship between psi and y. Why would this equaling a constant give you the thing you actually want, which is y? I don't know. Okay. So let's go to the more basic thing on integrating factors. That's the thing I actually was interested in figuring out. A function mu as yet undetermined. The question is now whether mu of t derivative. Whether we can choose mu of t so that the left-hand side is the derivative of the product mu of t times y. The left-hand side equation are they though? Oh, if we choose mu of t to satisfy that. Okay. You know what? Just from that, can I continue the example without looking at it? Um, is equal to 1/2. Integrate each side. So mu, oops, t. E to the 1/2 t plus c. What's up, mouse? So we found that the derivative of c e to the 1/2 t times y is equal to 1/2 c e to the 1/2 t e to the 1/3 t. Oh, okay. Then you integrate with respect to time. Okay, cool. This is how you get... Okay. This is making a lot more sense for where the formula comes from. You're gonna go to bed and dream of complex? All right. Good luck. Sleep well. Three plus 2, 5/6. Be jealous. I'm very jealous. I wish that I was the best mouse. Oh, that's kind of nice. The integrating factor will divide out. So we'll still get another integrating factor from that integral, but that's good. We want that. Importantly, this is on the outside. Exponent subtract. We get 2/6, which is 1/3 t plus c over 2e to the 1/2 t. Noish. Okay, so that's how integrating factors work for a first order linear equation. I knew it had something to do with the product rule, I just never quite knew what. Hopefully that actually sticks in my brain and I don't forget it the second I turn off the stream. So what's the deal with exact equations and their integrating factors? Similar idea, just a more complex... Well, it's the same idea, just a more complicated case. Okay, maybe let me go to Paul. It's been so long since we said hi to Paul. I want to see... Oh, sorry, this is first order. Um, how do you go from psi to just y? Uh, does Paul just tell you to set equal to a constant? Hmm. Man, I think this is getting glazed over. Why is that true? I don't know. I guess I'm gonna have to think about it. That's kind of annoying. Um, wait, the Wronskian comes up here? What is the Wronskian used for again? Oh, I do want to. I did say I wanted to look at existence and uniqueness. I'm just gonna skip ahead to the Wronskian. Oh, that's for variation of parameters, right? That's what they're doing here. Final mouse? I don't know who final mouse is. Wait, what section am I in? Variation parameters is down here. I'm in 3.2. I don't know. Differential operator notation. Hmm. Interesting. Actually, I kind of want to learn how you do all this stuff too, but I don't know if I want to do that right now. Do they talk about existence and uniqueness? They sure do. Just for first order to start off with. Actually, maybe reading through a proof isn't a good idea. Like I should do this off stream. Maybe I should actually pull a problem to do. Series solutions are kind of fun. Hey Mo, we doing well. I'm doing good too. I don't like a poison mouse, but I like a poison mouse. It's very confusing, Lucas. But hi. Did you read first or did you read first? Did I read first or did I read? What? I don't know what you're talking about, Lucas. Oh. The read as in red and the red as in red. Oh my god. I guess I read. That's where my brain went. I really am. I'm definitely not fully with it today. Ooh, I remember trying to solve Airy's equation back when I was doing my degree, and for whatever reason, I couldn't do it immediately and I stopped or something. See if I can redeem me of eons ago. Can 0 to the n equals 48? No, it can't. There's nothing you raise 0 to the power of to make it not 0. Well, you can raise it to the power of 0 to make it indeterminate, I guess. What about I? Oh gosh. 0 to the I. Well... the bad thing about 0 is what I would want to do is say that it's the same thing as e to the I ln of 0, but ln of 0 is undefined. So That's a no-go. What about well, what about the limit as r goes to 0 of some complex number e to the ri theta to the power of I? I sure oi? Yeah, I basically did. No, I don't really know what that's doing either. I assume it's just going to be 0. I have a hard time justifying that though. What does Wolfram Alpha do with this, I wonder? Wolfram Alpha says it's undefined. I don't know if Wolfram Alpha would do that in the way that we want it to, but I was kind of curious to see. It has to be 0. For example, 0 to the I squared is equal to 0 to the I times 0 to the I. But it's also equal to 0 to the negative 1. Wait, no. Yeah, because it's 2I. Oh, also, yeah, 0 to the negative 1 isn't good, right? I feel the same, Slim, so... For reason my brain just feels very slow today. Yeah, like I gotta imagine it's either 0 or undefined, but I'm leaning towards undefined because like what do you do with that? I wonder if someone has asked this. Here's a Reddit thread. This person is saying since element of 0 is undefined, so is 0 to the I. 0 over 0. It is undefined. There is a sense where it could be 1. Zero over 0 is 42 because 0 equals 0 times 42. Yeah, that's an actual like counterexample there. I over I is fine. So hey Zach. I remember Zach someone came into Zach's chat one day and really tried to like grill him about this. If you allow 0 over 0 to be equal to 1, like you could equally as validly say 0 over 0 equals 42 like Zach said, and rearrange it to be 0 equals 42 times 0, which that is a true equation, but so is this equation up here. And like, how do you choose just one thing? That's like the point that Zach is making there. Isn't x over 0 equal to infinitely big infinity and negative 2? It depends. Yeah, the exact thing that you wrote is undefined because you're just dividing by 0 and that's not defined. But the thing you're probably really talking about is a limit. And so if you want to talk about like the limit as x goes to 0 of like x over something, we could say a bunch of different things. So like we depending on what we put on the bottom here, we can get a bunch of different results. How's limit infinity for the actual 0 not? Because you're just not allowed to actually divide by 0. Like let's just take 1 over x squared just to simplify things a little bit. You would say that this is infinity. You would not say that 1 over 0 squared is infinity. What you're doing with this limit is you're dividing by numbers very close to 0, but not quite 0, and observing how they behave. That's what an epsilon delta proof is. And so in this case, you would be you would find that the numbers are unbounded the closer to 0 that you get. Like they're just getting higher and higher. And I'm talking about squared here because with 1 over x, it's a little bit weirder. They get infinitely big, but not infinity. Yes, but you can make it as big as you like. That's what she said. Hey, Abrar. And so, like, basically the way the epsilon delta proof works is someone would give you like, okay, can you make this number equal some huge number, like 1 Google to the 10 million? And you would say, yes, I can. And you would figure out what x value makes that. And they can name an even bigger number, and you'd be able to name an x that gives you that. And that x would be even closer to 0. So that's what we mean with like a statement like this here, that you can make it, it increases without bound. You can make it as high of a number as you want. It's not like this equal sign doesn't mean quite the same thing as the equal sign in 2 equals 2. Or at least if it does, it's for more subtle reasons. Why isn't x over 0 just x? You divide something by nothing so you have the same amount. Because we just can't divide by 0 in the first place. Like, it's going to... There's going to be a contradiction with that if you try to define it that way. Which I guess that's still what Zach... Like, okay, if you did say that x over 0 equals x, I could take this equation, multiply each side through by 0. So the zeros on the left cancel. We get x equals x times 0, but x times 0 is 0, so x equals 0. Yeah, Abrar, I can help out with logarithms. What's your question? Hmm. 12 objects divided into 4 groups, or 12 objects divided into 4 objects per group. Oh, weird. I have 5 potatoes, I share them with no one else. I still have 5 potatoes. But you are one person. You can't just not count yourself. You're really doing 5 divided by 1. Uh, so yeah, I mean, Nabar, it's a little bit vague, so I hope I don't explain something you already know, but if I were to introduce someone to logarithms for the very first time, the way that I think about logarithms is I start with an equation with exponents. So let's just say it's something that we know is true, like 2 cubed equals 8. You know, just 2 cubed is 2 times 2 times 2. So 4 times 2 equals 8. So this is an equation that we know is true. And we can translate that equation into logarithmic form. What we do is we say log base 2, because literally the base in this equation is 2 that's being raised to a power. And then it's log of the result 8 equals 3, the exponent. So logarithms find the exponent, like if you have 2 and you want to get to 8, the logarithm will tell you what exponent you need. Is basically like these two equations are the exact same thing. Um, and so this is a convenient thing. It just kind of will pop up in a lot of more advanced. Okay, can you tell me what then? Because I like I need you to tell me what part of logs you don't understand then. This is too vague. I'm sorry. Like you're gonna make me like talk for an hour before I actually get to the thing that you want to hear, I think. So I need to hear from you what you want to know. Okay, like do you want to know about the properties of logs? Do you want to know how to solve equations with logs, the derivatives of logs? Like this is you're not, school academic isn't telling me much about yeah, wooden logs. The log from Clash Royale. The definition of dividing that you share the numbers with the amount of other numbers there, just to make it a little more convenient. Log cabins, yeah. See, I'm sorry, bro. I like to help you here. I just I don't want to play hot and cold with the thing you actually want to hear about. Like like there's a lot that we could say about logs, and just saying a little more advanced isn't that helpful. I'm sorry. Companies aren't math, so logos of companies are undefined. Oh my god, Lucas, you're cooking. It was a programming language? I haven't heard of that. 2 to the power of 3 is what you want. What's the power of 2 is 3? Or to what power of 2 is 3? So yeah, I don't know, bro. If you only can put like an example of a question that you had trouble with or something. But unless I hear some more from you, I'm gonna move on to a different topic. Um, because 0 factorial and 1 factorial being the same doesn't lead to contradictions. Dividing by 0 and dividing by 1, that would lead to contradictions. It's what Zach was saying before, where for any particular thing you want to choose as a result of dividing by 0, you're going to get other things that look the exact same. Hey, Math Dork. Abrard. So yes, I know. So do you want to know about derivatives of logarithms, or are you talking about something new here? New? Okay, so what about derivatives do you want to know about? Yeah, it's a good day so far. I know there's a Wikipedia page about dividing by 0. So honestly, dividing by or division by 0 not working, um, it's an annoying thing, but it's actually a good thing for it to not be defined, because um it can help you think about how functions have weird behaviors when you try to divide by 0. Like 1 over x behaves weird around 0, and if division by 0 behaved perfectly well, like the this graph would look very different. I don't know why. It's a little bit too like weird of a thing to try to imagine, but bro, I'm sorry, this is still too vague. You need to tell me an example of a problem, because I don't know anything about your background, I guess. Like if you want to look derivatives in general, I can refer you to this like website that I really like, Paul's Online Notes. In Calc 1 and derivatives, there's a whole bunch of different things here. But um you're not giving me enough to go off of to really like help you out here. I'm sorry. I heard about that color cone. Yeah, that's sad. Oh, your 30 days ran out already? Gav, we've been talking about two things. So Lucas has talked about division by 0, and then Abrar is asking something about derivatives, but we don't know what quite yet. So I'm trying to find that out. I don't keep track of 30 days myself. I wrote like a little script that checks for it each time I hit start stream. Division by Zoro. That's a good one. 1 over 0 is 1 over 1 over infinity, and 1 over 1 over minus infinity. Uh, I need to write that out. Cadillo, welcome in. I've seen you around in Shane's chat. I recognize that name. That's awesome. Welcome in. Um, Glad to have you. If you have any like anything that you want to like hear about, let me know. Right now we're talking to Lucas about kind of like division by zero. Lucas seems to want to make it work, and I'm trying to figure out why it can't work because I never really questioned it for myself. So Lucas is starting off with these two statements. But then is saying that you could write this as 1 times infinity. So that's Lucas's justification for why 1 over 0 should equal infinity. Yeah, I'm trying to think about like, I, I, I think my opinion on that is the same as Zach's, where like you've already gone wrong. I mean, you've gone wrong in this step already when you divide by 0, but then you go wrong a second time when you just write infinity casually like this. I mean, okay, so when I wrote earlier that this equals infinity, I think this is kind of shorthand for something that's not actually proper to write. Like, I think it'd be more proper to write out in English, like, is unbounded. That's like technically what I actually mean when I say equal to infinity. Sounds like Zach agrees. Nobody's here. That looks terrible. I don't want to do that. Um. Oh yeah, and that arrow notation does exist too, where you some people also say like an arrow for approaches infinity. Doing math in the hyperreal numbers. And so I think it's never technically correct to use infinity in your equations like this. Okay, yeah, extended reals, that makes sense. Infinity can be minus infinity. We don't know because infinity isn't a number. Yeah, there's a certain sense where you could have yeah, I mean infinity gets even more complicated if you want to talk about like complex numbers as well. Because in real numbers you could get infinitely big or infinitely small. With complex numbers you can get infinitely big in any 360-degree direction. Subtended real number line? Someone's probably defined that just for the memes. So yeah, I guess like this would be I didn't realize that they did separately positive and negative infinity. They usually start doing stuff like this in like measure theory, right? You can also say 0 over 0 equals 1. You can't say that though, Lucas. So, okay. I feel like you're getting at how division is defined in the first place. Oh man, Abrar, I feel so bad. Like I'm not trying to be difficult here, but I would much rather you just put an example of a problem. Because I really, this is still, it's too vague. I'm sorry. Like I'd much rather see a type of problem or a type of function that you want to take the derivative of. Or like the product rule or the quotient rule or something. Oh, see ya. Nobody's here. I'm sorry. I'm not just trying to be like a jerk here. I really don't know what you're talking about. So Lucas, like, I think fundamentally, the way that we define division, um, I'm trying to remember how this works. It's called the division algorithm. Oh, I've heard that series says that. Yeah. Given a number p divided by q, we define division as sorry, I guess integer p divided by integer q as the I should just bring up the abstract algebra book and not try to remember what this is offhand. Like, I feel like, Lucas, we need to go to like the basic definition of division here and look at that. Because it's not going to work if we try to let one of the numbers be 0. Okay, let me just, I'm going to drag this in and talk about it. Okay, so what this is saying, the numbers that we're dividing are, this is basically how we define, when we do a divided by b, like this with a bar, what we actually mean is that we're setting up this equation, a equals bq plus r. And r is the remainder. And b is like the thing that you're multiplying. Like maybe it's easier to see if I do it with an actual example, because I'm kind of talking in circles here. If I want to do, say, 9 divided by 4, how it looks in this equation here is 9 equals 2 times 4 plus 1, because 4 goes into 8 2 times, and then you have a remainder of 1. And so that's how we define division at like the fundamental level. So if you wanted to take, I'll just take Brian's example of 3 divided by 0. If we go to set up this equation here, 3 is going to equal something times 0 plus some remainder. So this first number is always multiplied by 0. It doesn't really matter what we say here. I'll just put a 7 there, because why not? But that means the remainder is always going to be just 3. Like, this isn't really, like, meaningful. We're just getting 3 equals 3. So people need to mind their P's and Q's. I need to mind says B's and Q's. Oh, that's a neat train of thought, Brian, with the 2/1 thing. Oh gosh, this is a whole string of x's and zeros. If you wanted to find 0 over 0 as 1, then x over 0 1 times x over 0. And then you substitute that 1 to be 0 over 0. Which is equal to... Okay. You're playing real fast and loose with the math here, but I'm just going along with it. Which is equal to 0 over 0 times x, which is equal to 1 times x, which is just x. I like all this is coming back around to you're abusing notation in situations it wasn't meant for. And you're using properties like the property from this step to this step. It's not like you need to justify this separately because we haven't defined division by 0. Like, this is just a notation. It's meaningless unless you say what it actually means, which is like this stuff up here. Like you're building a castle on sand, basically. You need to define the fundamental thing first of what division is. Don knows math. Notation abuse. So that's what I was trying. That's what I was trying to do up here. It's kind of it's this process here, and so I guess the thing we should really be getting into is like defining improper like fractions. Which how do those work? Shit, dang it. Okay, I haven't like thought about how this algorithm actually works. If you have, say, or not improper fractions. That's an improper fraction. You know what? This isn't the actual definition. This is the algorithm. That's why. Improper fractions tend to leave their elbows on the table at dinner. Oh my god. Okay, yeah. So I this isn't the definition of the division. This is just how you do division. Zach is saying the real definition of division, which is the inverse of multiplication. And what that means this is getting really into the fundamental math that I haven't directly studied. So I'm trying to reach for how you like build this up. Oh, okay, yes, Lucas. That's perfect. Yeah. It's a number that you divide by to get you back to the identity. Except for 0. And that's the sticking point, I guess. Say functions aren't analytic at the poles. Maybe? Um, what's the point that I want to make here? I have a half-formed thought right now about like why this comes up, or like why we have so many issues with zero. And it's because like that's what you like most of all of math, really. You should really like get into like analysis, because that's where a lot of the stuff is built up. And I think like you could say like algebra too. So, sounds good, Zach. Thanks for the work and for your help with the question. Um, it's funny because like I was just like Matt Spellbook has been kind of like going through this process on his stream, um, and how we kind of build up our number system, um, and just like how we talk about the real numbers. So um, like we need to have zero in our real numbers because that's how we define additive inverses. So zero is important because for addition, we define the additive inverse as whatever number, like for given number a, the additive inverse is the number you add to a to get you to zero. And zero has a special role as the additive identity, you would call it. Because anything plus zero is itself. But now when you want to go define multiplication on your numbers, that has a different identity, which is 1. And you said build up to real numbers. Yeah, and so that's a really cool thing to watch you do, or you two do. Um, and so the multiplicative inverse is whatever number you multiply a by to get to the identity, the multiplicative identity. So it's 1 over a. Um, and so the issue, there should be an issue that happens now when we try to let a equal 0. And I'm trying to figure it out in a non-circular way. Because if I just say, like, there is no, we don't even need to do like 1 over a. We could just say like some number b. There is no number b that makes this equation true, I guess. When a equals a over a is 1, even for 0. No, you're only allowed to, like, if you start with a equals a, you're only allowed to divide through by a if you stipulate that a is not 0. We're often not very careful about it in math when we take an equation and divide it through by something. But whenever you divide by something, you do have to make sure this is true technically. It just usually doesn't matter. A equals MC to the 99 because of 0. I have to think about what you're saying with that, Lucas. Hey, Bob. We've been talking about Lucas about why you can't divide by 0. And I'm kind of like reaching for how to get at why, basically. to have a proper definition, you have to make sure that multiplicative, that the multiplicative inverse exists and are unique. Yeah, I guess like how you would find the multiplicative inverse naturally. So I kind of cut to the chase when I wrote this. If you want to figure out what the multiplicative inverse should be, you would like, be given a number A. We want to multiply it by some other number B such that AB equals 1. And so we'd want to solve this. But the issue is that if we're given A equals 0, then we have 0 times B equals 1. And there is nothing we can say for B that would get us to 1. Only think about multiplication. We're not allowed to divide yet because we haven't defined it yet. Isn't it heinous to say what I say is true? It would lead to some kind of like contradiction. It is the issue. It's like 8 as x goes 0, 2 over x. It's always 2. Now you can include 0 over 0 is 2. So all the way over my head, my simple mind is telling me you can't divide by 0 because there's nothing to divide by. Yeah, there's a lot of different ways to interpret division. And honestly, I feel kind of out of my depth here too. Like I feel like I should know the answer, but I kind of don't. It's not like thoroughly. So yeah, like the background for people who don't know Lucas is like Lucas is just a very like curious, like towards the end of high school student. And so we often have these kind of just like random conversations, just kind of exploring math. So this is just a thing that Lucas like just enjoys thinking about and trying to like justify. Yeah, yeah. So I don't think Lucas is like really trying to like say that this is the right way to do math, being allowed to divide by 0, but like why not? Yes and no. Okay, well maybe you don't want this to be the way that we do math. That's fair. Like this is a thing that you know myself or someone like or like like your math teacher should be able to like answer and like help you with, but it's kind of not a common thing for students to like to ask about. So I'm kind of struggling for a very clean explanation of it. They actually know probably so many times 0 to the 0 is 1 without knowing. I did not know that. When I read that, I was like, really? We just kind of take it to be 1? I know if you can L'Hopital's it. That's what I usually do if I encounter that. Or you can become like Terrence Howard. That's true, you could. What are you talking about, Bob, with the 0 to the 0 thing? Yeah, Lucas, like I'm kind of like excited for you to eventually take like an analysis class or whatever class where they like kind of build up math from scratch, because I think this is like really what you're getting at here. And I haven't like done that for myself, so I'm kind of like trying to figure it out on the fly here. Taylor expansion of e to the 0. What? It's in like math philosophy. Ooh, that's cool. A lot of mathematicians have been philosophers also. Oh, so this is an issue. Yeah, are we defining the Taylor series as this, or are we defining the Taylor series as this? Because there's a massive difference here for what you're saying, Bob. That's so weird. Just like a difference in the notation kind of causes it an issue there. Specific areas that require certain axioms. Combinatorics of 0 to the 0 equals 1, and calc it's undetermined. Ooh, I hadn't heard that for combinatorics. Found another way to justify that? Oh, okay, Lucas. In almost every way except the limit is 0 to the x. Really? Oh yeah, so what's the deal with x to the x? I assume we do e stuff. And then you gotta L'Hopital's that. Oh yeah, okay, yeah. I'm just gonna take your word for that because I don't want to do it. I have done this before. Oh, but you're saying if you have 0 to the x, I guess this would just be 0? Is that the point that you're making, that these aren't quite the same? X to the nth power squared. Wait, x to the n. Wait, squared to the n? I don't know what you're saying, Lucas. I'm getting like 3 levels of exponents here from how I'm reading it. Physics specifically, it's useful to use 0 to 0 as 1 in so many cases. So you get differences between language and what works. Yeah, I've never like knowingly like assumed that. I've always tried to use L'Hopital's or something to justify it. The nth root. The nth root and the nth power of x. Oh. It's like the nth root of x to the n? Or also like x to the n over n, you could say. This should equal x, I guess, yeah, Lucas. If you're about to plug in n equals 0, though, there's going to be an issue. Like, what would be like what would be the 0th root of 2? Can't say I've ever done that. Infinity? Because you're thinking limit as x goes to 0 of 2 to the 1 over x. And okay, yeah, and so that okay, yeah, I see that. Yeah. Wait. It's undefined? Really? Can go from negative infinity. Oh, still lurking? No worries, Zach. Just couldn't resist the relevant stack exchange thread. Because it go from negative to positive, negative or positive. Oh yeah, I guess yeah, you need to define the sightedness. What level of math is taught until age 17, 18? The minimum that was required for my high school, I think, was algebra 2, which is like finding roots of parabolas type of math. I went and did basically 2 semesters of calculus by the time I was 18, though. For it's like differential and integration calculus. So it depends what part of the country that you're in, but I'd say like that's, you know, people are more typically towards the lower end of the spectrum there with like algebra basically. Swarth Mohammed, I majored in applied math, minored in computer science. And wait, did this prove 0 over 0 is 1? Okay. If we made like a graph of Lucas's thoughts on 0 over 0, it's like good, bad, good, bad, good, bad. It's like a stock chart. But hey, no, that's math. Hyper operation? I don't know what this sentence means, but let's ignore that. It's not an answerable question in any practical interpretation of the word answerable. Oh, it's a funny sentence. Oh, it's not invertible because hey, yeah, okay. We had such a different system in the UK, doing like roots, quadratic formula, and all that stuff. 14 to 16. 16 to 18 was pure statistics and mechanics. Yeah, I know in general, like the EU has a way higher emphasis on pure math, whereas America is more kind of calculations and applied, usually, at least early on. I was like, you know, in the more advanced classes, so I was ahead of a lot of the people I like graduated with. I say I was probably like about on par with you, I think. Where when I was 17 to 18, I was learning about derivatives, integrals. I could have done calculus-based physics. I think I chose not to, and I think I just did algebra-based physics instead. But that was just mechanics. I also did statistics, not calculus-based, but like learning all the tests, z test, t test, chi-square. It's like for everyone in the UK. uh, my classmates were complaining endlessly about the level of math that they had to get up to. That definitely would not fly here without a lot of work in the gradual process. In complex analysis algebra, z equals r cosine plus I sine. We define the nth root. I guess so. This notation L. The nth root of z to the n of z. Oh, true. Yeah. That trip, because I've been learning about complex analysis, and I got tripped up on that exact thing where there's multiple like cube roots and stuff. Trying to make graphics. Oh, nice. All right, listening, Bob. In the meantime, I'm gonna write out Lucas's most recent train of thought. 0 to the 0 over 0 is 0 to the 0 times 0 to the 1 over 0. I don't agree with that if you're trying to use like exponent identities. Do I agree with that? I can't tell. Maybe I don't know how this works. Maybe it's right, maybe it's not. So to do physics at uni, you had to have done physics and maths at A level. A level maths had no calc in it at all. So you hear lectures say every first year. Oh, interesting. Yeah, I've done some A-level problems. They're probably I've done like A-level further maths problems, I should say, and those are probably harder than anything I had to do, but not by much. Yeah, I don't know how it is in other countries, but in America, there's very much a common attitude among students to just do the minimum to get to the piece of paper. For me, I did the minimum to get an A and then to get the piece of paper. Because I was just basically programmed to always get A's to the extent that I could. Ilfrem's about the same as first year uni. Yeah, that's what yeah, the classes that it's like in America we have AP classes like advanced placement. They can take during high school on the way into university. And those are your university level classes that I did a good amount of. My AP classes were pretty much exactly the same in terms of difficulty as the university classes. Getting everyone up to scratch mathematically, yeah. Oh gosh, all right. Focus. Another string of ones and zeros. Let's see. 0 to the 0. Oh. Oh. So you're doing 0 to the 0 plus 0 to the 1 over 0. You're factoring... Oh, wait. No, this should be multiplication here. If you want to add the exponents. Um, it's a now you're claiming 0 plus 1 over 0 is 1 over 0. And now you're saying that 1 over 0 is equal to 1? You weren't even saying that before, though, were you? I'm questioning from that exponent to that exponent. Oh, x over 0 equals x. Okay. You skipped your advanced level like it's high school, and now I'm studying in a private campus. Can you give me the math lessons that I should study in order to do a computer science degree? For computer science, I mean, it depends on the university. They're probably going to make you do calculus and linear algebra and discrete math. I think are the typical ones. Honestly, you should just start with the calculus, because that's usually what they make you do first, and that's already a big enough topic on its own. And the thing that I like to recommend people is Paul's online notes. It goes over, like, you want to learn stuff from like the calculus 1 and 2 tabs. And if you don't feel comfortable with the prerequisites, go into the algebra tab and look at this stuff. That's where I'd start. I have too many things open. I had 2 tabs of Paul open. I'm all Pauled up. Okay, so wait, let me scroll. I see your comments, Gov. Let me just keep on with what Lucas said before. Then I'll scroll down. So 0. Okay, and so from this stage, Lucas was saying. So 1 times 0, the 1 over 0. It's equal to 0 to the 1 over 0. Times 0, or wait, equals 0 to the 1. Equals 0. Oh, but then you got, actually, that works. Okay, I'm not sure where we're going with this, Lucas. Then on from there, you can take more math classes. This last year, I took one called Theory Toolbox, which is complex analysis differential equations methods for Bennius series expansions, eigenfunctions, and green functions. Ooh. George Green was from the town where my uni is from. He has a library named after him. Spent half your life in George Green Library. Who's... is that George Green of Green's theory fame? Should there be an E on the end of that? Or what I'm saying Green's theorem, I mean like the double integral equals a line integral. He was from Nottingham. Oh wait, isn't there an E on Green's theorem? Am I crazy? I thought there's a third E. I thought it was spelled weird. No, I made that up. Okay. I don't know why I thought there was an extra E. I don't think it's weird to have a textbook with a table of contents at the end of the book. That is weird. What kind of textbook has it at the end? They're the same thing? Okay, maybe. But I wonder if it was famously misspelled somewhere or something. I don't know. That's awesome, though. He has a library named after him. Guess what I'm saying is unjustified. Mandela effect? Yeah, that's the term. The page number is relative to the chapter you're in, not. Is that made to torture people? That has to be like the least successful way to organize a book. You feel like you're on a good path with the division by zero thing? Um, I I'm not quite sure what to tell you other than if you try to define it, you're almost certainly gonna introduce some type of contradiction in your system of math. I didn't quite follow it. I just saw your conclusion, which is that it was unjustified, but you're saying this is equal to 0 times x. Are you saying that 0 over 0 equals 0 now? Like, this 0 comes from that 0 over 0? Dolphino, welcome in. 0 to the 0 equals 1 over e double factorial? Or just you're excited about and those are exclamation points? Limit as x goes to infinity, 1 over x. Just excited, okay. I love it. To the power of 1 over ln x. Bourbaki's book? Oh, is that a Bourbaki's book? Dang. Through direct substitution is 0 to the 0. Is it? Oh, okay, yeah, no, I assume it was 0 to the 0. But it equals e to the minus ln x over ln x, which is 1 over e. Let's follow along with this. Um, e to the minus ln x over ln x. Oh, wow. It's 1 over e. That's funny, yeah, I guess you can kind of get anything you want if you set up the right function. How do you even define that x to the 0 equals 1? How do you prove the following? 0 to the 0 is 1, x to the 0 is 1, 0 to the x is 1. That obscure result in linear algebra, you just give up and try to prove it yourself. I think the reason why something to the 0 is 1, I think that might just be a definition thing. The justification that I usually use or think about is just like looking at the patterns where, like, just say, let's start with like 2 squared, 2 to the 1, 2 to the 0, 2 to the minus 1, 2 to the minus 2. 2 squared is 4. 2 to the 1 is 2. Skipping over 2 to the 0. 2 to the minus 1 is 1/2. 2 to the minus 2 is 1/4. The thing that kind of fills in, the natural thing to fill in the blank here is 1. Because if you think about it as going down the line, we're dividing by 2 each time. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2. So it just continues the pattern. If you start trying to do 0 to the x, though, 0, it's not 1. 0 to the 0 can be 1 in the limit sense, but it's not actually 1. And 0 to any other power is 0. Division rules for exponents? Oh, maybe. How do you define negative exponents? That's a good question. I don't think I know the answer to that. It's not immediately. How do you define negative exponents? I don't know. I'd have to Google it, I guess. I guess it's that what Bob said. It wouldn't be true. Well, yeah, if you want to do it for x equals 0, you're going to be dividing by 0 on the right-hand side. So this definition isn't valid for x equals 0 because 0 to the minus n is fine as long as n isn't 0. But then you get division by 0 over here, and that's bad. It doesn't equal 1. It only equals 1 in the limit sense. 0 to the 0 is just indeterminate, is what we call it. Zero over zero is in a, like, 0 over 0 is in a similar category as 0 divided by 0, as weird things that we don't usually define as anything. And it's not that you can't define them, it's that it's bad to define them. The cube root of x and x to the 1/3 are different functions. I did not realize that point, Gallus. Why is that? Did I make myself bleed? I think I accidentally dug into my finger a little bit too much with my nail or something. That was a while ago because it's not like actively bleeding. Anyway, um, all right, Lucas. In the meantime, I'm gonna go back to my FIQ stuff. Okay, so trying to solve Airy's equation with series. Thank you, thank you. Be right back or not. Yeah. Papadoria, with regard to what Poingal said, I think it has something to do with the idea that x to the 2 over 6 has the domain of all real numbers, but x to the 1/3 doesn't. X to the 1/3 is fine with negative numbers, right? Like, -1 to the 1/3 is -1? Hopefully? I'm no good, Mohammed. How about you? 2 plus 3 minus 5 over 2 plus 3 minus 5 is 1. There you go. They're defined for different ranges of x. The first one on R, the second one on 0 to plus infinity. Really? Are fractional exponents only defined? I thought you only had a problem with like even denominators. But I thought odd denominators are fine. Fractional exponents, negative numbers. You do raise an interesting point there, Papadori, with saying that 1/3 is equal to 2 over 6. A negative base is a point of conflict between the three commonly used meanings of exponentiation. For the continuous real exponentiation operator, you're not allowed to have a negative base. For the discrete, oh my god, I didn't realize there are 3 different definitions. That does seem like an obscure result in linear algebra. Papadori is saying GeoGebra just sets them equal for you. I wonder how GeoGebra, if GeoGebra just always takes a certain definition. Yeah, I mean, for something like this, I wouldn't necessarily trust graphing software though. I feel like, or you need to understand like how they're graphing it, like what definition they take. Because I've had someone explain to me that there's an issue. I don't completely understand. There is an issue with negative bases, and I've had someone point out like a pretty easy to get contradiction for certain like bases with certain exponents. I don't remember what it was though. It was too long ago. Hmm. I don't know what to think about that. What's my actual job? Right now it's nothing. I'm in the very lucky position of getting to pretend to be a full-time streamer and just live off savings. Um, I do a little bit of private tutoring on the side, but not enough to like make a living on that. I used to work HR, basically like human resources. I burnt out on that, but I saved a lot of money. And starting in 2 months, I'm gonna start on a master's in applied math. So the short answer is that I'm unemployed. uh, Take this example: -2 to the 2/6, -2 to the 1/3. Sixth root of 4. Equal to the third root of -2. One is positive, one is negative, therefore they can't be equal. Oh yeah, fair. Oh yeah, Gov. To be honest, I'd love to just be a streamer. I really love doing this. It's kind of like I may as well buy a lottery ticket though, so it's not something to really like depend on. Second equal sign. Oh yeah, I'm sorry. I saw you made it like an arrow, and I was like, I wonder if that's a typo. So, yeah, especially that Gov. I think there's real potential in streams like this to become a bigger thing on Twitch. Uh, but that's not built overnight. And even if it's not, like, it might take someone who understands the internet better than like the people who are doing it right now to actually like make it something big. I understand what you mean with the arrow now, Papadoria. That like that goes with that and that goes with that. Yeah. So if she starts trying to solve the twin prime conjecture. No, I mean like the thing that I'd love to do is just like help people out with their homework. Like I'd love to just like uh answer like people's calculus problems all day or something like that. So I started playing chess, speedrunning FL Studio. I don't think I've heard of that. Um, so music production. You can do a speed run of that? How do you do that? Like who can produce a song the fastest? Speedrun making the beat for a song? That's kind of hilarious. Okay, I think I got this second derivative of y correct. So what we do is we plug it into Airy's equation. Let's do this right. N minus 1 a sub n x to the n minus 2 minus, I'm going to bring the x inside the summation instantly. A sub n x to the n plus 1 equals 0. FL Studio speedruns are just who can make a beat for a song the fastest. Since FL Studio has a bunch of hotkeys for like copying chords and merging sounds and a bunch of other things, it's cool. Like, what? Can you just make a really crappy beat though? Like, how do you define what a beat is? Like, I could just say like, I don't know why I did that sound, but I could say like that's a beat. Just put it on loop. 17 seconds. All right, we can watch this. A beat. Oh, like an existing beat. Whoa. On one hand, that's cool. On the other hand, what's the point of this? I guess what's the point of speedrunning anything? Maybe I shouldn't question that, I guess. But like, I wonder how this started. Yeah, God, that is an interesting question. Probably 100. Yeah. I feel like I need a keyboard cam to really appreciate this. Because what's happening on the screen just kind of doesn't seem that special. Maybe it's, I guess. I don't know. I don't know. Maybe he's not doing a bunch of shortcuts. FL Studio speedrun? All right. I had never heard of these. Man, why is it all shorts? So can, oh, 8 million? No, 17? I don't know who's the... $12 million? The guy with the dreads? Like that guy? Rob? This is wild. His Preds on Snapchat? That is a hell of a career change. Yeah, that is, it's kind of insane that he can do that. Like, I feel like that would translate to good, like, StarCraft skills. That's where my mind is going. World record FL Studio speedrunner to Pred catcher. Both are respectable. A Dota player? Yeah. Oh, my music isn't playing. I was wondering why it was so quiet. He's posting about that on YouTube too. I think the goal with this is we want to get the indexes to match so we can get them in one summation. So we can either take the first few terms of this and separate them out, but I think you prefer to turn time back here. Okay, I remember like how this works. Because I usually get this wrong. So we need this starts at 2, but if we're going to force this to be 0, then that should be n plus 2. This starts at 1, but we're forcing it to start from 0, so it's n plus 1. This starts at a sub 2, so we want a sub n plus 2. That starts at 0, so we want x to the n. Okay, nice. Now how does this work? We need to get a recurrence relation out of this. The thing is, we want to get rid of like the x's that are being multiplied, because that's cramping our style. You know what? The x's not having a matching exponent is kind of bad as well. I wonder... Probably need to do something a little bit different than the exact thing that I did here. We probably need to be fancy with this. Like we need to... So we want the index to match and for the exponents to match, I think. I was thinking about that, Delfino, is that we're gonna get an... If I were to continue on this with that idea, the thing that was giving me pause was the x right here. I'm not quite a fan of. I think in theory, like you could say like, you know, x isn't generally 0, so take this bit here equal to 0. But it's going to be difficult to solve for a sub n if there's an x being annoying. Maybe it's not if we just treat it as a constant. I'm also kind of ignoring the fact that this is a summation. I think it's still valid to kind of forget about it and set that bit equal to 0. I don't know exactly why though. Just to see what the world would be like. If I wanted to get that to be x to the n, I would start the series from n equals 1. Well, then the issue is I could throw out the first term of that. No, I would hate to do that. Okay, you know what? This is an example from a textbook. Let's maybe look at the first bit for a hint. So this is the example problem where it starts. Yep, got that. Got this. Starting the sum at 1. So they... Oh! I remember you do get a constant up front sometimes with this. Oh, and you... okay. Right. You can justify that setting equal to 0 from what Penlock said with comparing the coefficients. Okay, so the first series, we just manually write out the first terms separately. The second series, we turn time forward. I don't know why I think about it as like turning time forward or back, but because it's kind of not what you're doing, but let's take this and make it our own. Oh wait, no, you do have to also rewrite that. Okay, undo. There you go. So get the powers of x to match, and then separately, we'll get the starting index to match. So when n equals 0 in that first one, we get a sub 2 times 2. Let's save a bit of time. Okay. Oh, I didn't even see that. Efficients. Okay, so from comparing coefficients, well, okay, we need to think about these always have a coefficient of x at least. So we can say that a2 must equal 0. And then we can say, because we think of this as like 0 plus 0x plus 0x squared plus ... We can then justify saying that n plus 2 times n plus 1 a sub n plus 2 minus a sub n minus 1 is equal to 0. And now it's solved that recurrence relation, which is annoying. So the way that I did this in my differential equations class was just to plug numbers in and hope you notice a pattern. There's definitely better ways to solve recurrence relations. But let's see what we can get with this. So we know a sub 2 is 0. Do you know anything about a sub 0 or a sub 1? No, we can get it in terms of a sub 0 and a sub 1. We can take them as constants. Yeah, it's second order, so we do get two constants. I think that's what you do with those. Okay, so if I let n equal 3, Suna, hello, I am doing good. I hope you are too. Actually, no, I want to get a 4. So I'm going to let n equals 2. Four times 3 times a4. Wait, do I want a3? I'm trying to remember how series solutions to differential equations work. So this is the original problem statement at the top here. It's kind of a neat thing. I haven't done it in a minute. But you can solve differential equations with Taylor series. It can get pretty messy, but it does work. And so basically, if you do enough work, you can get a recurrence relation out of it that you have to then solve. And that's really the entire problem. Like, I guess I should explain, like, you assume that y has a Taylor series representation like that. And the only thing you really have to find, you already know how y looks. The only thing you have to find is what a sub n is. And so that's what all this work is going to be about. It's your arch nemesis, Mr. Differential Equation in disguise. Yeah. And so from the way they're phrasing like this m powers of x, I assume it's not going to, like, whatever series we find isn't going to have like, what would you call, like, an elementary function representation? Like, it's not going to be like something simple like sine or cosine, I don't think. It's going to be something that's just stuck as a series that doesn't easily translate to a regular function. 3 times 2 times a3 minus a0 is 0. a3 is a0 over 6. So 1 equals 0. I should really rearrange this to not have to do this algebra every time. So we're going to have to write out quite a few terms here, so let's just save some space. Uh, 4 times 3 is 12. A sub 2, which is 0. You're not doing this anymore. So much hope for this. You guess your ego's a little too high. It's worth exploring and playing around with math like that, Lucas. Uh, 6 times 5 is 30. Should I be multiplying it? Maybe I shouldn't be multiplying it. A sub 3 is a sub 0. 6 times 5 times 3 times 2. What do you mean by having to do the algebra every time? It's been just like a general form for all n. Can you just plug in numbers? Oh, I meant like I was plugging. Right now I'm just plugging numbers in for n and trying to spot a pattern. I was plugging into this equation, and every time I was adding this over and then dividing by that. So I just wrote out this thing instead to do that for me. I was just giving myself a lot of extra work for no reason. A sub 4. 9 times 8, but a sub 4, a sub 1 over 9 times 8 times 4 times 3. With n equals 6, we should just get 0. There's a way to solve recurrence relations with like polynomials. It kind of makes me uncomfortable though, because I don't understand it. So I'm doing the very brute force thing of just trying to guess it, basically. It's the aim, yeah. It's kind of a weird. It's not the best example to see it at first with. For my differential equations class, I chose this as a topic to do a presentation on. And if you just like, if you start with a simpler one, like y prime minus y equals 0, like the answer is just e to the t, well, times a constant. If you wanted to do it the long way with series though, it's not too bad. You basically just take that for your form of the solution for y, take the derivative. N times a sub n, x to the n minus 1, and then you plug these both into the original differential equation and kind of rearrange things from there to try to figure out what a sub n is. And you do end up with the power series for e. I need to go out one more level, unfortunately. So n equals 7. A sub 9 is a sub 6. I already got 9. Oh my, that's why it doesn't, that's why I can't see the pattern. I did that wrong. 7 times 6. Sorry, I don't remember exactly like where you're at in your studies. That was like a bonus topic that I chose to learn about. My differential equations class didn't actually even like cover it. Oh, nice. I really loved it, the differential equations. So I'm glad to hear that. A sub 6 is that thing up there. I'm definitely doing this the caveman way though. Ooga booga. N equals 7. Ooga booga, n equals 8. This is the last one that I'm doing. A sub 7, 10 times 9. It's going to be a sub 1. 10 times 9 times 7 times 6 times 4 times 3. Okay. I don't know. it's going to be annoying to explicitly write this out. But I'm getting two different things. How do we deal with this again? We have to do two separate definitions for a sub n. So these more complicated things. Oh, nice. So we have three different possibilities for a. So if a is a multiple of 3, it's equal to a sub 0 over um 3n minus 1 times 3n minus 3, 3n minus 4, dot, 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 times 3 times 2. I think is the best that we can really do with that. Hey, Saptarshi. If n is a multiple of 3 plus 1, we get a sub 1 over 3n plus 1, 3n times 3n plus 1 minus 3, so minus 2. Times 3n minus 3, dot, 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 times 4 times 3. What a sequence of numbers. And if a is 3n plus 2, my favorite is 0. Because it's way easier to write. Okay, and so I think we have to split this series up based on what they are mod 3. So y is going to equal a0. It's just, an a0 is just any constant that's determined by your initial conditions. From n equals 0 n equals 1 to infinity. We need to separate out the 0 case manually, don't we? I guess we do. Y is equal to a0 plus a0 times I guess this trash. X to the 3n plus a1 n equals 0 to infinity. This trash. I need to make sure the indexes are right here. Indices. Neither, Saptarshi. This is this came from a differential equations question. I have to solve it with series though, which is why series have come up here. This arrow is no longer needed. And I think I have my answer here. I'm just trying to make sure it makes sense to me. What powers of x do we want to cover? Okay, any time n equals 3. Oh wait, did I make a goof? I'm looking at that base down there. I should be looking at this value of n. Ugh. I goofed. I goofed. I done goofed. So if n equals 1, we want these coefficients. So that's 1 mod 3. And I think we make it start from 0. As long as it's understood that when n equals 0, we have that. But and then when n equals 2, so 2 mod 3, we have that. I feel like I messed this part up. I'm gonna be real. Let's see what the answer is, because I'm kind of sick of shoveling symbols around the page now. Okay, so this is probably a smarter way to write it out, rather than trying to make it into a the notation like I did. 1. Does what I say agree though? I think my fix was important. I think I should have gotten rid of my first A0 that was on the outside. Then A1. Oh, I messed up A1. No, I messed this up. I had it right the first time. Oh, that's annoying. Okay. Clonk, I hope you're doing well. Each time I open up your stream to say hi, it's like right at the end. I've been meaning to say hi though. Confused again. Why is x to the a times x to the b, x to the a plus b? Why is that true? If we have 2 cubed times 2 to the 4th. Oh, okay, because you, let me do, okay, yeah, because you could write 2 cubed as 2 times 2 times 2, and 2 to the 4th as 2 times 2 times 2 times 2. So you could then regroup these to be 2 to the 7. And so I think you do the same thing with like the A's and B's, you just get dot dot dots. Okay, that might be it for me for the day though. Ugh. It's a pretty good math session though. It's annoying. I nearly had this right, and then and then I mess it up. Saptarshi, I'm from America. I've gotten quite a few people who ask about JEE questions, and I've tried them so many times, and I just kind of fail at the JEE Advanced, at least in particular. That I just kind of gave up on them. So they 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 just use very weird tricks that aren't taught here, and I just don't have like the background for it. But it's a really popular thing for people to ask about, to the point where I just started to pin that, because I feel like I was saying it so many times each stream. So I definitely wish that I could help with it. It just would take so much effort in studying that I prefer not to. But yeah, I do think I'm going to call it there. We also used to fail in advanced questions. Yeah, it's not an easy test. But yes, I'm going to cut the YouTube stream off here. On Twitch, we'll look for a raid. So Septarshi, anyone else who's here, thanks for being here. Sorry they caught me right at the end there, Septarshi, but it's been 4 hours, so yeah. See you, YouTube.